So we've worked with a lot of data, and part of what we have to do as statisticians is summarize our data. We have to present it in a way that can summarize things so that you can make sense, draw big conclusions from them. And there's no shortage of ways that you can do that. Let's start off on page 60 here with a Pareto chart. And the only difference here between this and a histogram is that you put these bars in order of the most frequent to the least frequent. So basically it's a frequency histogram in descending order. That's all a Pareto chart is. Pie charts, I imagine you've seen these here, there, and everywhere as you move around the world. Very common way. What happens is that the frequency is drawn in proportion to the area. And that's a nice way to say, you know, where your data lies. So very common type of display there. Other displays that you'll see are frequency polygons. So instead of drawing a histogram with a bar this high, you'll just connect a bunch of dots, and that's a frequency histogram. And this connection of dots replaces your frequency bars. So again, it's a matter of taste, convenience, software, whatever you like. And all of those are pretty cool. Let's see what else we got. I think we got time series and dot plots. So your data might represent something as a function of time. But there's problems with data as well. And this exemplifies one. So on the left, you've got nausea experienced by patients in an experiment with OxyContin versus a placebo. And the first graph is fine. Looks like there's not a big difference between the placebo group or it looks like there's a huge difference between the placebo group and the OxyContin group, right? I mean, boy, you're going to experience nausea way more frequently with OxyContin than you will a placebo. But there's something wrong with this graph, something that's not really fair if you're trying to present this in a way that doesn't deceive people. It doesn't start at 0. Take a look at where it starts. It starts at 10%. So what you're seeing is an exaggerated difference between these two graphs. If you started this graph at 0, percentage of people experiencing nausea between placebo and OxyContin group, well, it's certainly noticeable, but it's not nearly as dramatic as it was over here. And that's because you're starting this graph at 0. So it makes a huge difference. This first graph is very deceptive. I mean, if you don't look at it very carefully, you think OxyContin is way worse than a placebo in terms of experiencing nausea. So that's kind of a problem. Let's see. Here's another one that's kind of deceptive. Now it talks about the percentages of people who smoked in the US in the 1970s and then again in 2013. Now what you're seeing is that, okay, yeah, this larger cigarette is about twice as long as the other one, and 37% is about twice as much as 18%. But there's a little subtlety going on here that you might not realize. This cigarette is drawn at least 2-dimensionally. Actually looks like it has a 3-dimensional object or perspective to it. And the total volume or area here is much more than the total volume, it's much more than double the total area or volume of this one here. So it's exaggerating or dramatizing the difference between these two. It's not really very easy or fair to compare these because they're not drawn to scale. I mean, the length is fine, but the area isn't. And that over exaggerates the difference here. It looks like a much bigger decline from 1970 to 2013 than there really was. So now let's show you a couple cool examples of some data display that that exists in our modern world. And I found these just recently, and let's see if I can't pull them up. And I hope they're going to run good. This is a two-parter, and by no means do I mean to make any political statement. I just love this guy's data presentation. It's just so cool.
All right, here's the Andrew Yang argument in 60 seconds or less. Andrew Yang ran for president last year. His main argument was that the reason Donald Trump won the 2016 election was because of the loss of manufacturing jobs.
That's really cool. So these are the manufacturing jobs that existed in numbers of millions, starting sometime in the early 1900s all the way up to 1970, and then going down. But it gets better.
In the U.S. So we can see here, this is looking at 1939 to today, that the peak was around 1979, where we had almost 20 million manufacturing jobs. But today, we're around 12.8 million. And that really is around 2000. From 2000 on, we see this decline in the number of jobs in manufacturing. And so his argument is that those job losses are really played out in key swing states, and that's where the election was lost. And so let's look at those actual states. So let's break this out, and we can see that yes, in Indiana, Michigan, Missouri, Ohio, Pennsylvania, Wisconsin, that yes, there was that precipitous decline in jobs. So that part of the argument does hold up. And his real point is, what's next? Where's automation leading to next?
All right, so that's part one, and I'm sorry I don't have this done up in two parts, but I do have a second part for us. So let's see the conclusion, because I love what he does with all those dots. It's just amazing.
Point is, what's next? Where's automation leading to next? And so if we look at each of these dots that represents 4,000 US workers and start to order them, where are they working? They're working in retail. There are people working in food services, people working as truck drivers. That these are the next jobs to be automated. And where does that leave us as a country when we lose those jobs? And I think especially now with COVID helping propel the automation forward even faster, how do we move forward as a country? And I think I love his statement, not left, not right, but forward. Thank you. Andrew Yang, 60 seconds.
Okay, so, wow. I mean, that's amazing data manipulation. If you can teach me how to do that, I'll give you extra credit, because that was pretty cool. But I just wanted to show you that there's a lot of ways to present some data, but it doesn't always have to be high tech. In fact, one of the most famous displays of data is over 100 years old. This is Napoleon's March on Moscow. So, and I forget who was it created this. I think he was like a retiree, but there's just so much information in this data set that is displayed in this graphic. So first of all, the width of this line represents the size of Napoleon's army. And then underneath here, you've got a table that represents, the temperature, how cold it was as he's marching on Moscow. Now, what happened is, I think he started in like Lithuania or Belarus or someplace like that. As he marched on Moscow, the Russians just kept on falling back. And, the French army, as big as it was equipped for summer fighting. They weren't equipped for the winter. And you can see what's happening to the numbers as they get closer and closer to Moscow. They're dwindling. They're dwindling. So it's telling you where they were. It's showing you the dates at which they were there. It shows you their eventual arrival at Moscow. Look at that. They lost 27,000 people in a battle just before they got to Moscow. They got to Moscow, and guess what? Moscow was burned. They burned it to the ground. In fact, the Russians had a scorched earth policy so that the Napoleon's armies couldn't feed itself from the land. They just starved and they froze. And it was just a disastrous march. And take a look at things. When you got back, your army of 420 some thousand was only 10,000 strong. Wow, just amazing. But low tech, but just full of information there. So nice. You got a nice little chronology of exactly what happened with this battle. So are we going to be that high tech with things or low tech or creative? Probably not, but we can do things in a nice, fun, creative way. So let's go back to our data set with the eruption times for Old Faithful. And let's again highlight just our data. So I'll click here and highlight. And one of the things we can do is get a time series. Now this is not time series data, but we can get our own charts from Google Sheets. If you go up to, where is it? Insert, and then chart. If you select insert and then chart, Google Sheets is gonna try and predict what chart you need. And in this case, it's gonna predict for us line chart, which is what I want for us. Come on, let me try that again. Oh, there we go. No, that's not quite the one that I wanted. We can set up these things and customize them, different charts, customize. Yeah, I'm gonna get rid of this one. Delete that chart. Naturally, as I'm trying to finish things up, it's not doing what I expected. Let's see, data in Google Sheets, insert charts. Boy, I did this one right before class too, and it worked out good. What's going on here? Oh, let's see. All right, this is the one that I wanted to do that for. So let me send you the data into the chat. And get it to you that way. Chat, everyone. Oh, is that all coming through? Yes. Can you grab the data out of the chat? Just maybe copy that and paste it into a fresh Google Sheet. And this is actually problem number 10. So while you do that, let me pull up problem number 10. Let's see, what page is that going to be on?
It hasn't come through, or at least not for me.
Yeah,
No?
Are you talking about the Zoom chat? Because it's not in there. Yeah, it's not going to work because the spacing is off. So it just gives us.
Is it not a column? Is it not coming through as a column?
It
First of all,
literally just came in.
No, I just.
Okay. So I'm hoping that you can just copy the column of data and paste it into Google's chat or Google Sheets. And while you do that, let me show you where the data comes from. So that's going to be page 65 here. 65. There you go. The number of home runs starting in 1990. And so one of the things that I mentioned as we went through all these different ways to display data was you can do a time series, in which case you plot everything based on what a sequence. So if we put that in our Google Sheets, there we go right there. If you click on this and highlight all your data, let's try this again where we're going to insert a chart. So I'll click insert and then chart, and bam. It chose for us a nice line chart, which is exactly what I wanted. And then you can look at this and try and see, are there any trends in the data? It looked like around here was the peak in terms of number of home runs, and then things kind of dwindled down. It looks like pitchers got wise to things. Maybe this is when baseball started cracking down on steroids, not sure. All right, but there seemed like a little bit of a trend down after that. So that's all I was looking for on that one, was to help you find that line chart. Were you able to get that one up and working?
Yes.
Yep.
Okay, wonderful, wonderful. Let's see. I think that's about all I want for this section. So are there any questions from tonight? No, looking good. All right, let me stop this right here.